On the screen, we see here open tube manometer. What is the purpose of open tube manometer? The purpose of open tube manometer is to measure the pressure of a gas. Whenever we are dealing with the gas and we want to find out what is the pressure of the gas, then in laboratory, we can use this device. You see, in this open tube manometer, we are going to follow one principle. That principle is Gay-Lussac's law. Gay-Lussac's law. And according to this Gay-Lussac law, if you change the temperature of the container D, then pressure of the gas inside the container D is also changing. So pressure of the gas inside the container will depend upon the temperature of the container D. So what is exactly the Gay-Lussac law? The Gay-Lussac law says that the pressure of a given mass of a gas is directly proportional to its absolute temperature. So temperature changing, pressure of the gas inside the container D is also changing. Here we cannot change the quantity of the gas unless and until you change the quantity of gas. Here the condition is that in given container you cannot change the quantity of the gas. If the quantity of the gas is maintained a constant, then pressure is directly proportional to absolute temperature. So this idea we are using in open tube manometer. This open tube manometer having two sides. One side is open to atmosphere and other side is closed. And other end of manometer is connected to some container D. Inside this manometer, we use two types of liquids. One is the liquids of low density or liquids of high density. When you want to measure the low pressures, so in that case, we use the low density liquids such as water and kerosene. And when we want to measure the high pressures, we use mercury. Let A be the point towards the open atmosphere and C be the point which is towards the container D. When the pressure in the container D increases, it pushes C in the downward direction and C goes down and A goes up like this. So C goes down and A goes up. Now from point C, draw a line so that it is extended to the left limb. Call this point as a point B inside the liquid. So we have the point A and point B. The distance between point A and point B is equals to h. The point B and point C are same height with compared to bottom of the tube. Therefore, pressure at point B equals to pressure at point C. Pressure depends upon height of the liquid column from the bottom of the container. If the height is remaining same, pressure also same. Therefore, pressure at B, that is PB, equals to pressure at C, that is equals to PC. So from A to B, this is a liquid column. The pressure in this liquid column is nothing but depends upon the three factors: height, density of the liquid, and gravitational acceleration. And at the pressure at point A, that is nothing but atmospheric pressure, that is P naught. Therefore, total pressure at point B, that is PB, is equals to addition of atmospheric pressure and plus pressure due to liquid column, that is H rho G. So total pressure at point B equals to P naught plus H rho G, that is addition of atmospheric pressure plus pressure due to liquid column. Now, according to Pascal law, pressure at point C, that is PC, is equals to pressure at D. So PC equals to PD. This is as per as Pascal law. But PV equals to PC and PV is given by P naught plus H rho G. Therefore, PC is equals to P naught plus H rho G. That is pressure inside the container D is equals to PC, that is equals to P naught plus H rho G. So PC is the addition of P naught plus H rho G. That implies the pressure due to gas. The gas is present in entire container D and that gas is exerting pressure at point C. So our aim is to find out the pressure due to the gas inside the container. The pressure is changing in the container D. Why the pressure changing in container D? When you change the temperature. When you change the temperature of the container D, then pressure of gas in the container D also will change. And we want to find out that pressure of the gas. So the pressure of the gas in the container D is equals to the pressure at point C. Therefore PC equals to PD. And this P naught plus H rho G is the pressure at point T. So PC minus P naught, that is equals to H rho G. PC minus P naught, nothing but gauge pressure. That is gauge pressure measured by the manometer of the gas inside the container. So in this experiment we have measured the gauge pressure. What is the use of manometer here? The use of manometer is nothing but to measure the gauge pressure of the gas inside the container D.